Okay, so our last part on electrolysis. Now you'll see with the picture, instead of having two separate half cells, we just have everything in one container here. Um, we still have the battery driving the reaction, but we're going to be dealing with the same species. Now we have a silver electrode here, and then it's in a silver solution. So silver sulfate, nitrate, whatever it is. And then on the cathode side, that's where you're going to have your object that you want to plate. So here I have, you all know that I draw so lovely. Here is a spoon. So I want this cheap metal spoon to be silver plated. Now my anode has to be my source for that AG1 plus. So that silver metal is going to be my anode. That I want to dissolve into AG1 plus so that those electrons can go through, come down that spoon, and then the Ag plus 1 can grab the electrons and plate onto that spoon. The thing that's going to be plated is always the cathode, and that's because, remember, at the cathode, that's going to be the reduction where you're gaining the electrons. That's where you're going to be making that solid metal again. And so you can see by the half reactions, almost like a concentration cell here, but concentration isn't driving this reaction, the battery is. We've got our silver solid losing the electron and becoming silver 1 plus, and then those silver ions in the solution, some from the ones that just got dissolved, others that are just part of the solution, gaining those electrons once those electrons go from the anode to the cathode, and then grabbing them and plating onto that spoon. Everything's still the same as the other cell I depicted. Your anode is going to be hooked up to the positive end of the battery. Your cathode is going to be hooked up to the negative end. But now we can solve this question here, and you're actually going to be doing this in lab on Tuesday. We want to know what mass of silver would plate if a current of 6.8 amps flowed through for 72 minutes. Now this is just going to end up being a dimensional analysis problem, but we have a one factor that I gave you several days ago. Well, now we're going to get our chance to use it. We need to know that our 1 amp is equal to 1 coulomb per second. Okay, so now when I set this up, that 72 minutes, as you can see, I got to get that into seconds. So I'm going to start with 72 minutes, and I'm going to multiply that by 60 seconds is in 1 minute. Okay, now I am in seconds. Now I want to get into coulombs. So since I keep saying angstrom, but 1 amp is equal to 1 coulomb per second. So if I have 6.8 amps, I have 6.8 coulombs per second. And so I meant to put a multiply here. We are going to have 6.8 coulombs. Let me just erase that. Make it a little bit nicer. This program's not very forgiving. 6.8 coulombs over 1 second. So now my minutes are canceled, my seconds are canceled, and now I'm kind of at a hold up here. When we have these coulombs, that Faraday's constant, 1 mole of electrons is equal to 96,485 coulombs, what we've been using in our other equations. So that's kind of another known conversion factor there. Now I can get it into grams. I've got 1 electron, so 1 moles of electrons, because my silver is losing 1 and gaining 1. If this was copper, you could see either losing 1 or losing 2, depending on what copper it is. But in this case, we're only dealing with 1. 1 mole of E for every mole of silver. And now I can convert that into grams. 1 mole of silver. When I look it up on the table, now I'm running out of space here. I'm going to have to kind of write to the side. We got 107.87 grams. Our moles of E cancels, our moles of silver cancels, and we're left with grams of silver. And when we do everything up, we end up with 32.8 grams of silver. Okay, since we're dealing with 2 significant figs, we'll probably bring this to 33 grams of silver. So what does this mean? It means if we were to hook a system like this up to a battery and set the current to 6.8 amps or coulombs per second, and we let it sit for 72 minutes, 33 grams of silver is going to plate onto that spoon. And depending on how thick you want the layer, that's what's going to determine how long something is going to sit in the electrolytic cell like that. And like I said, you will be doing this in lab on Tuesday. You won't be dealing with silver, unfortunately, but you will be dealing with copper.